Welcome back, ladies and gentlemen. We're now going to move on to our Module 7 video, which is protein and muscle protein synthesis. So we're going to talk a little bit about a few different things in this. We're going to talk a little bit about what muscle protein synthesis is, muscle protein breakdown, and what net protein balance is, and why net protein balance is important, and what we can do to influence it. I'm going to talk a little bit about protein quantity and muscle protein synthesis thresholds, and also protein quality falls into that as well. And then we're going to talk about optimizing muscle protein synthesis to get the best benefit from our nutrient intake as well. And then we're going to talk a little bit about protein recommendations and considerations. Okay, so let's crack on with it. So within this video, we're going to talk a lot about muscle protein synthesis and muscle protein breakdown. So obviously protein synthesis can take part in a number of different ways. There are a lot of proteins in the body, and many of them are outlined in your module text that are online. So we're going to focus on muscles on this because that's what we're most interested in, and that's one of the things we can optimize through training and on nutrition. So a positive net protein balance is essential for laying down new muscle tissue. This is called muscle accretion, muscle tissue accretion, and this can be achieved in two different ways. So we're looking to optimize both these things. So one is by increasing muscle protein synthesis. So the more synthesis, the more generation of proteins we have, obviously the more muscle we can have. And also, if we can reduce the amount of muscle protein breakdown. This one's a bit misleading because we actually need some muscle protein breakdown to remove our damaged proteins, to remove our damaged enzymes from within our muscles, and to remove that damaged tissue that we're then going to regenerate. And we do need some muscle protein breakdown. So that's why hormones like cortisol, for example, are elevated quite highly from training. So yes, we want to control cortisol like we've discussed previously, but a little bit of cortisol is essential to actually help initiate those processes and to remove that waste protein that we don't want, so we can replace it with new, stronger muscle fibers, muscle tissue. So basically, the synergistic effect of protein ingestion with exercise potentiate the muscle synthetic response. This basically swings net protein balance in our favor for muscle protein accretion, thereby permitting muscle hypertrophy when practiced frequently over time. So what this means is that by manipulating those two muscle protein synthesis and muscle protein breakdown variables, over time we can actually swing this in our favor to actually lay down muscle tissue, and it's a combination of resistance training with appropriate nutritional strategies over time is going to actually generate that muscle hypertrophy there. So that's a good quote. It's a good paper to find if you can find that. I think it's a free text paper, so that's quite easy to look at. And what we need to also consider as well, in states of inadequate caloric intake or catabolic disease, the overall breakdown of cell proteins, especially in skeletal muscle tissue, increases to provide the organism, which would be us, with amino acids essential for gluconeogenesis, again, the creation of glucose from non-glucose sources, for new proteins and energy production. So bearing in mind that we need to be aware of this sort of thing when we're on a calorie restriction, which is why we keep our protein high. One, to preserve muscle tissue. Two, to provide some substrate, particularly on those lower days like we talked about in the last video, to actually use to produce glucose as well. There's some interesting research that has recently just been released. I'll try and put it onto the reading list, or I'll send it out in an email at some point if I don't remind me about this paper, which is saying actually we can actually develop lean muscle tissue actually on quite a severe calorie restriction of up to 40%. Bearing in mind though that was in a very sort of unusual population. It was like, I think it was people just starting out lifting, so that might not be applicable to everybody. But if you do want to see the paper on that, which shows that you can actually build muscle and lose fat on a calorie deficit, which is something that has been a big debate. It is possible in certain situations. I'm not saying that's possible for everybody under all such situations, but definitely it is a possible thing to do. So with that said, what's the most amount of muscle we can build a day? The estimates are between 5 and 10 grams of muscle per day, and that is assuming there is optimal muscle protein synthesis. So if we don't have optimal MPS, we're not going to lay down that muscle tissue. So if we think 10 grams a day and over 365 days a year, that's 3.6 kilos of muscle a year, which obviously in the earlier stages you're going to grow a bit quicker, but for an average person, of an age where their testosterone levels are still adequate, the growth hormones still adequate, they're healthy, 5 to 10 grams of muscle per day is the most you could accrete. It doesn't sound a lot, but if you think about that over a 5, 6, 7, 10 year period, then that's a lot of muscle tissue to put down. Obviously within that you're going to get your genetic freaks of this world, the guys who lay down muscle quicker, but for most people that's where you're going to fall in that range, okay? And that may seem a a small amount for some people, but actually once your training age is maybe 10 plus years, I think a lot of people would quite happily take maybe sort of 1.5 to 2 kilograms of lean muscle tissue growth a year. But that's why it's important to really consider generating optimal muscle protein synthesis, because without that we could be lower. So yes, you can still grow muscle without considering some of the strategies we're going to discuss within this, but you're certainly going to be inhibiting your maximum growth potential. So we're going to talk a little about some strategies that can be used to optimize that. Okay, so I talk a little about leucine and MPS. So leucine is the main trigger of muscle protein synthesis. Now, when people talk about protein quality, there's a bit of a misconception with this. Like, most people would think about, grass-fed meats, well-farmed meats, ethically farmed meats. That's not really what we talk about when we mean protein quality. When we're talking about protein quality, what we're talking about is the leucine content. Now, leucine is the main nutritional trigger of MPS, muscle protein synthesis. So how do we know this? Well, first what they did is they looked in animal models and humans as well, and they looked to stimulate protein synthesis. So they fed essential versus your non-essential amino acids. And what they found was that the essential amino acids triggered muscle protein synthesis and the non-essential ones didn't. So then what they did was they compared the branched chain amino acids, which are all essential, so your leucine, isoleucine and valine, versus your non-essential non-BCAA essential amino acids. Okay, so then they found that, well, the branched chain amino acids triggered protein synthesis. So then they compared isoleucine, leucine and valine, and what they figured out was that leucine was the main trigger. So they just did this by trial and error, and they just looked at protein fractional turnover rate, so on and so forth, which is a thing called fractional synthetic rate, which is basically just a measure of protein turnover in the body. We'll talk about that a little bit when we talk about the studies on protein. So yeah, they basically just did a trial and error kind of thing, but a very sort of systematic way, and they found that leucine was the only amino acid that triggers protein synthesis, and it appears that it's about 2 to 3 grams of leucine triggers muscle protein synthesis, but you still need the other amino acids to build muscle. I think I've said it before, that leucine is the conductor of the orchestra, but you still need the other musicians and the other instruments to be able to make the music. Okay, so remember that just because muscle protein synthesis is triggered, it still needs the other amino acids there to actually build muscle as well. They're responsible for the construction of those proteins. So in the last video, we looked at how proteins were created. So it does take a long chain of different amino acids to create those proteins. So why leucine? Why would this make sense? Well, it makes sense because it makes sense to have one regulator of muscle protein synthesis, something that is going to get into your body unaffected, because it's not really broken down, it's not really adjusted by digestion or in the absorption processes, so that when this gets to the cells of the body knows that other amino acids are going to come, so that they can then trigger protein synthesis, because it knows those nutrients are going to be there. So protein quality relates to, one, the leucine content, and two, the amino acid profile. So the amino acid profile is how many of the essential and non-essential amino acids does it take. So meat sources, dairy sources are higher quality proteins, something that vegetarians don't often want to hear, or vegans don't want to hear. They are higher quality proteins because they have a larger amount of leucine. Okay, that remains intact. Leucine triggers muscle protein synthesis, and they also have complete amino acids. So that's always a consideration for vegetarians and vegans, is to make sure that they have enough of a variety of protein sources in their diet that have the full spectrum of amino acids. So that might be piecing together different plant sources that contain amino acids, but even then it is likely that the protein quality measured by leucine is going to be lower. So supplementation, in this case, the only real plant source which has a moderate to high amount of leucine in it is soy protein as well. But do some reading about soy proteins. I don't want to get into it within this video. There can be some issues with it. It's just a case of looking at the pros and cons for vegetarian and vegan clients, and then making a decision from there. Because otherwise, vegan in particular, if they can't use whey proteins, is very restricted on this. And yes, it might not be such an issue in the general population where protein quantity counts, but you can't, if you're an athlete and you're trying to recover, it's not just the quantity of protein that matters, it's the quality of it as well. So 200 grams of protein from wheat sources, various other plant sources, isn't going to have the same muscle protein synthesis stimulating effect as something was having 200 grams of protein from dairy, meat sources, fish, so on and so forth as well. Okay. So at the bottom image there, what we can see there is we've got a little pathway of what stimulates muscle protein synthesis. So we've got insulin and growth factors. They influence a enzyme called P13 kinase, and that stimulates mTOR. Now, mTOR is the mammalian target of rapamycin, which is just a main pathway that stimulates muscle protein synthesis. So you can see it there. So those things can influence P13 kinase. So the other thing that will influence it there is leucine. So that and resistance training will influence that pathway as well to actually upregulate muscle protein synthesis. Now, why have I put these things there? Well, there's a couple of reasons. Firstly, like always, to guide further reading if you go want to learn about this stuff. But if you ever look at any papers or if you get into the science of training, a lot of these enzymes will be evident in these sort of papers. You'll see these names dotted around the place a lot. Okay, so P13K, mTOR, and then there's this one on the right hand side. It's called AMP kinase, which is adenosine monophosphorkinase. Okay, which is an inhibitor of mTOR. So this is an important consideration. We'll talk about why in a little minute. But AMP kinase is basically it's the fuel gauge for your cells. Okay, so when your fuel is low in your cell, so if you haven't got many fatty acids or glucose or glycogen within your cell, your AMP kinase levels actually rise up, and that inhibits mTOR. So this is something we need to consider when we're looking at nutritional strategies and protein feeding as well. So having enough protein in a diet is one thing, but we also need to make sure that we provide enough fuel that we stop this inhibitory pathway. Okay, so that stops mTOR. So AMP kinase stops mTOR, right? So it doesn't matter how much leucine and stuff you've got, it doesn't matter about your growth factors, this AMP kinase is going to inhibit your mTOR pathway, which is your main muscle protein synthesis pathway. Okay, so that's a very oversimplified version, but those terms are ones that will crop up in the literature a lot if you are interested in this kind of thing. There are also other intermediary steps as well, which have got a lot of other long, sort of slightly confusing sounding enzymes within there as well. But don't be put off by the names. They sound confusing, but fundamentally they're not really. All they are is just enzymes that perform some function that lead from one process to another. Again, if you're interested in that, take your time to read it. If not, this is a basic amount of information that will help you get through. So if you do want to explain this to someone else, or you're just interested yourself, this should be enough to sufficiently see why leucine is important, okay? And why other things like insulin, stimulating that around training through carbohydrate feeding. Obviously, that's going to improve your AMP kinase response because you're going to have energy there, and it's also going to stop muscle protein breakdown as well through that process. Because insulin stops muscle protein breakdown pretty much dead as well. So it's one of the reasons why if we feed carbohydrates around training, particularly if we're dieting and we've got a restricted carbohydrate intake, taking some carbohydrate around your training is going to actually help preserve muscle proteins as well. So it's going to inhibit that breakdown. So not all of it, but a number to a large extent protein breakdown. So it's very difficult to actually lose muscle tissue if you've got an adequate amount of carbohydrates in your diet. So if we wanted further evidence that leucine was important and it's a measure of protein quality, we need to look at these two graphs here. Okay, so each source of these, each of these protein sources will be matched for protein content. So not like 100 grams of each product, but each product might contain, say, 50 grams of protein. So what we've got on our bottom left-hand graph here, we've got FSR, which is our fractional synthetic rate. Without getting to the complexities of what it means, it's fundamentally just a measure of protein synthesis, protein turnover, okay? So at baseline, we have some protein turnover going on. So, we have amino acids in our body, we have some stored in our liver, we have some in our muscle, that's turning over all the time. So there's always some turnover of protein. So then when we feed with our wheat product, what we find is that we get a little bit of an increase in protein synthetic rate, but not too much. Soy about the same as wheat. But then what happens when we've got egg is that if you look at that, you get a 10% increase in fractional synthetic rate, which equates to about 80% increase in muscle protein synthesis, okay? That's a massive jump in protein synthesis for a very small change in fractional synthetic rate. And again, you get an even bigger jump, okay? So what we can tell from that graph on the left is that we're starting to see that the source of our protein, not just the amount of our protein, is actually important for stimulating muscle protein synthesis. So to link it back into leucine, if we then look at the graph on our right, our histogram on the right, we can see that baseline obviously has got no leucine in it as well, so our plasma leucine levels are relatively stable. Wheat, again, doesn't go up very much. Soy, there's a little bit of leucine in it in soybean. Soy isolates have actually got higher amounts of leucine in it, so that's why I'd recommend that as a supplement for vegetarians or vegans. But then look at egg and whey. Again, there's no coincidence that as the plasma leucine levels rise because of the leucine content within those supplements within those foods or supplement, that you then get this big jump in protein synthesis, okay? So there's further evidence that in terms of protein quality, that's massively important than just the amount of protein in the diet. So quality over quantity every single time. Okay, so now we've dealt with protein quality and quantity to an extent. Now we need to think about protein distribution. So how often do we need to eat protein and in what amount? So we know we need to stimulate protein synthesis by eating 2 to 3 grams of leucine. In some people it might be higher, okay? So 5 grams, we're playing it safe there. If we look at the top graph here, we've broken into two halves. On the left, would be an even distribution of feeding. So we've got 30 grams of protein at breakfast, 30 grams at lunch, 30 grams at dinner. On the right-hand side would be what we classify as maybe a typical sort of Western eating pattern. We don't have much protein with breakfast typically. We usually have cereals of some sort. So we get less than 10 grams of protein at breakfast, 20 grams of lunch at protein, and we have most of our meat or our protein sources at dinner time there as well. So what we see there is on the left, where we've got the even distribution of protein, we're still stimulating muscle protein synthesis maximally, but over a number of periods of the day. Obviously, this is going to be greater benefits in terms of muscle growth. Now on the right hand side, you can see there the dinner, the 60 grams of protein, we're stimulating muscle protein synthesis just the once at dinner time. Now, one of the issues with this, and it's something that I'll feed back into with thinking of certain diet strategies which may encourage periods of fasting, which may be beneficial in some ways like insulin sensitivity, but in terms of protein synthesis, it's definitely not. And the reason for that is this: it doesn't matter how much protein you have or how much leucine you have, okay? It will only stimulate muscle protein synthesis to a certain level. Okay, and then those excess proteins that you've eaten, those excess amino acids will either be, converted to glucose for energy if they're in too much of an excess, or excreted, or broken down in some other way and contribute to some other form of protein synthesis in the body. But fundamentally, they will not be taking part in building muscle tissue, okay, or stimulating muscle tissue anymore. So this is one of the reasons why we actually look for eating little and often as bodybuilders. So it's not just made up nonsense, and it's nothing to do with stimulating metabolism to a certain extent. It's to do with, if we're eating protein regularly, we're going to stimulate protein synthesis more often. So we can see that eating protein in more even distributions is better, but the next question really comes down to, well, how often should we eat protein? This leads us down onto our bottom graphs here. So if we look at the bottom graph on the left, we've got our FSR, which is our fractional synthetic rate again, so our measure of protein synthesis. And on our right, we've got plasma leucine. And the first thing that should jump out with you straight away is that our fractional synthetic rate, so if we have our feeding time at 0 minutes, then we've got along the bottom 45, 90, 135, 180, and 225 minutes, give or take. Okay, we have our protein feeding, and our protein synthetic rate goes up. Peaks just before around about 90 minutes on this graph, and then it comes back down, goes to around about 3 hours, it's back down towards sort of baseline, okay? What's interesting is, if we then took our blood plasma leucine, so we measured the leucine in our blood, it rises a little bit quicker, because it will do, because it's going to then trigger that process. So your plasma leucine is going to be higher in your blood, because it then has got to be delivered to your tissues to then stimulate protein synthesis. But if we look at the plasma leucine, it stays elevated for up to 3 hours, 3+ hours, okay? Well, this is interesting. So what could be happening by which our protein synthesis is dropping, but our leucine's still high, even though we've discussed that leucine is the main driver of protein synthesis? This doesn't make sense. Could it be provision of amino acids, because the leucine isn't being used up as much, so the other ones are, possibly? But it's also related to that AMP kinase we discussed previously as well. So bear in mind when these are taken, these are done in like a fasted state, so there's no energy provision within that. So one thing we look at then is if AMP kinase there's no energy provided to drive muscle protein synthesis, then muscle protein synthesis is going to be reduced, and that is exactly what was hypothesized to be happening here. So it appears that we need to be feeding carbohydrates or fatty acids either with our proteinous meals or in the gaps in between. So if one of the things we could do is, for example, is to feed proteins at around about the sort of 135-minute mark. Proteins, feed carbohydrates or fatty acids around the 135-minute mark, okay, and that will actually help improve muscle protein synthesis, because that will inhibit the AMP kinase, okay, so that will fill our gas tank up, which will inhibit our AMP kinase, okay. Alternatively, we have mixed meals. It's unlikely with the digestion and absorption of carbohydrates and fats as well as your proteins that realistically you're going to get this fall in fractional synthetic rate. There's no studies that I've seen that have looked at this, but if you look at the steady supply of food, steady supply of nutrients, particularly your energy macronutrients, so your carbohydrates and your fats, if you have those regularly with your protein source, with the digestion and absorption rates, the reality is you're probably not going to get this drop off of fractional synthetic rate. But what it does point to in terms of protein feeding is making sure that you have protein every 3 to 4 hours. Now, in certain conditions, that's going to be different. If you're dieting, you might want to make it more frequently because it's going to feel more satiating. In dieting, because of the higher cortisol levels, okay, you're going to find that your body's going to break down tissue that little bit quicker, so you might need more protein within those periods. And obviously then there's people with different genetics as well. So some people might find that they need to eat protein every 2 hours. Some people may slightly longer, depending on the rate their body turns it over. This is just a trial and error thing. But as a general rule, for most of the population, you're looking at protein feedings every 3 to 4 hours would provide enough protein, with enough protein, would provide optimal protein synthesis. Okay. Okay, so that this presentation, this video was quite short and sweet. There's quite a lot of information within a small period on this one, so please go away, feel free to do some reading about it as well, and look at the influence of how resistance training and sort of various hormones have on muscle protein synthesis. There's enough out there. Hopefully now you've got a basic understanding, and what I've just shared on this last slide is the link to that study I was talking about earlier about higher and lower dietary protein intakes on an energy deficit, don't wrong with me today, energy deficit combined with intense exercise, which promoted greater lean mass gain and fat mass loss. So this is one of the first studies of its time. This is very recent, from 2016. Okay, so the link's there, so you should be able to copy that down and then just find that paper there and have a read through it. And hopefully by now you've now got the tools to understand what all that data means. Like I said before, there's a few different papers on protein that have come out recently that have showed that you can actually lose body fat and gain muscle at the same time. But again, I'm very cautious to apply that in terms of most population, especially people who've trained for a long time with a large training age, you know, who've maximised their sort of natural genetic potential from that perspective as well. On a final note, I just wanted to thank you again for watching this video. Some of the things here are going to be very useful for you for your career, I would imagine, in terms of, you know, discussing things like protein synthesis in terms of protein feeding and stuff, and justifying why you use certain feeding strategies. So one of the advantages that you can see over this compared to something like intermittent fasting, for example, is that you're actually providing nutrients all day long, stimulating protein synthesis all day long. Which this could be a challenging thing to do with something like an intermittent fasting kind of protocol. Okay, I think you've also seen as well the awareness now of that protein quantity isn't necessarily the main driver of protein synthesis, so quality is also very important. So we also need to be aware, if we're dealing with vegetarian or vegan clients, or you're a vegetarian or vegan yourself, not to be dogmatic about, you know, meat is good, meat is healthier, because you can still have a healthy vegetarian or vegan diet. But we need to cut through some of this BS and some of these myths, because a lot of propaganda that goes out there that's saying that vegetarian and vegan diets are healthier than a Western diet, which is true, but a typical Western diet isn't healthy. But any diet which requires you to supplement with things that provide amino acids or essential fatty acids can't inherently be healthier than a diet that does. People might argue with me on that logic, but if you need to supplement to have essential things in your diet, that diet can't be beneficial for you from a health or even an evolutionary perspective. So for me, the argument for vegetarian and veganism is one based around morality, and that's fine. That's very fluid. It's very individual. You know, there's an argument to be said that in a world where we can eat healthily without needing to eat meat, should we? That's a question I'll let you answer personally for yourself. But the debate isn't around whether it's healthier or whether that you shouldn't use supplements, because any good sports nutritionist, any honest vegan or vegetarian that isn't just trying to sell propaganda will acknowledge that, you know, there are limitations to these diets. So please be aware of that. And if you have those kind of clients, like I say, it's not about trying to tell them they should eat meat, but it's just about being aware that there are limitations, particularly within vegans who can't have things like whey protein or any sort of milk or egg sources of protein as well. So yeah, you need to be able to factor those things in, and as a good coach you should be able to write a good diet for everybody regardless of their restrictions. You know, there might be religious reasons why they don't eat certain meat as well. So yeah, these things need to be accounted for, and now hopefully you understand why and how to do those things. So yeah, again, thanks for listening. Hope you enjoyed that. Short and sweet, and I will sure you will hear from me very soon. Happy learning.